Welcome to a lesson with Dr. Powell. Let's take a look at how we can find the angle between two different planes in 3 dimensions. So suppose we have something like 2x minus 3y plus 4z is equal to 7. And maybe we have x plus 2y minus 5z is equal to 1. What's the angle made between these two planes? Well, the angle made between these two planes, let's say you have a plane here and a plane here. Finding the angle, maybe it comes out this way and that way, or whatever. Um, well, what if we just thought of a vector that's orthogonal to one and a vector that's orthogonal to the other one, and like that. Now, this angle is going to be the exact same as that angle. So really, we just need to find the angle between the two vectors that are orthogonal to each one. How can you see a vector that's orthogonal to a plane? Well, it's sitting right here in front of you. It's just the coefficients. Oh, well, you need to include that negative there, I guess. So let's just do that. Okay, that negative and that 4. So you have one vector, 2, -3, 4. You have another one right here, the coefficients 1, 2, and -5. So we want to find the angle between these two guys. And that's pretty much all we need to do. So to find angle between them, let's just think. We got one vector, we got the other vector. Be nice if we could just make a right triangle. We got to, you pick one to project onto the other one, and then we can find this angle pretty easily. Okay, if we had this projective length and that, we'd be set to go. In fact, maybe even a little bit more simply though, if we, yeah, that works. Let's just do that. I mean, either way is fine. So what we get is we need to know, let's pick maybe this one right here, let's let be the top one, and this one right here, let's let that be the bottom vector. Now, so that to get a projection of one onto the other one, it's just dot product. If the one you're projecting onto is a unit vector, but this one's not a unit vector. So to make it a unit vector, we multiply it by 1 over its length, which is 1 squared plus 2 squared plus 5 squared, which happens to be 30. So square root of 30. Okay, so now it's just dot product. So we get 2 and -6 and -20. Okay, so we end up getting -26, so -24, -24 all over square root of 30. And that's going to be, so what is this? This is the projected length right here. That's that projected length. So we have at least 2 legs of the triangle. We have this one. We also have this one if we just take the length of this guy right here. So let's do that. The length of that guy is 2 squared plus 3 squared plus 4 squared. So that's 4 plus 9 plus 16, which would be 29. So 29, so square root of 29. So we got square root of 29, and we got this guy. So we got to find that angle. So this angle right here is just going to be the inverse cosine. It's because this is adjacent over hypotenuse of adjacent divided by hypotenuse. So adjacent's this, and if you divide by hypotenuse, it's like throwing this into the denominator down here. So we get -24 over the square root of 30, and then you've thrown down the square root of 29 in the denominator since you're dividing by it, and we're good. Right there with that, you can compute that and you figure out what the angle is, and that's all. That's how you can find the angle between these two different planes. Thanks for watching.